And I'm delighted to be here with our presenters who are joining us remotely. They are from US, so it's quite late over there, but they're going to bring energy, hopefully. It's Hannah Hess, Associate Director from Climate Impact Lab, and Herberto Tapia, who's Head of Research and Partnerships at United Nations Development Program. Let me see if this works. Yeah. This launch is an important milestone in this initiative that we started about 2 years ago. And then last year, we released the first version of the platform, which provided information on temperature, including impacts on people, on mortality, energy, and labor productivity. This ambition is to provide everyone with peer-reviewed scientific information quantifying true costs of climate change. Sorry. Yeah, this is skipping a little bit, but it's okay. So the platform is a window into possible futures. It provides information for 3 time horizons over the 21st century, and it provides information for 3 emission scenarios, which outline our collective policy choices. The platform also provides information for all countries and territories, including 24,000 subnational regions and areas, including many of the large cities, over 500,000 in population. So with that, now we're going to have a short video to get us started, then we're going to go to panel discussion and conversation.
The world stands at a critical juncture in the face of climate change. Human Climate Horizons, a data and insights platform built upon peer-reviewed, frontier scientific information, enables all of us to see both global and hyperlocal projections of human impacts of climate change for all countries and territories worldwide. In its new release, the platform unveils projections of sea level rise and impacts on coastal land and people living in coastal areas. These projections offer a glimpse into possible futures, considering 3 time horizons over the 21st century and 3 emission scenarios that underscore our policy choices. The platform also shows how these impacts compare across countries and regions, highlighting where some of us are most at risk and where local and collective responses are most needed. There is still time to take action and make a change. Human Climate Horizons is a partnership initiative between UNDP and Climate Impact Lab, ensuring equal access to climate data connected with human development indicators. Join us in shaping our local and shared paths forward.
Okay, so that's a short summary. And now we're going to turn to Hannah, who's going to tell us a little bit more about key findings from this recent release on sea level rise and impact on population in coastal regions worldwide, and some new interesting information about this new release. You can go to
research collaboration formed in 2016. For those not familiar with the Climate Impact Lab, which I would guess is true for most of this audience, our mission is to measure and communicate the impacts of climate change to empower effective decision-making. One consequence of a warming climate that we measure is rising sea levels, which elevate the risks of flooding and permanent inundation to coastal communities worldwide. Our methods and framework for estimating climate change impacts have been peer-reviewed and published in top scientific and economic journals. One important application of those climate impact projections is estimating the future benefits of policies to reduce emissions, and therefore reduce climate damages, using a metric called the social cost of greenhouse gases. In the process of conducting this research and building these social cost estimates, our team produces the sort of high-quality, detailed, and forward-looking climate information that is key to unlocking a more resilient future. This partnership with colleagues at the UN Development Program is one we are very grateful for, because of its potential to ensure that information doesn't get stuck in academia, but is available to all, helping us to think about the human impacts of our path forward, how to accelerate climate mitigation, and how to adapt to those impacts that we can't avoid. The platform, in its latest release, brings forth projections of future sea level rise under different possible emission scenarios. Critical information for coastal planners and policymakers trying to understand and account for sea level rise impacts on their communities. Here are global average projections of sea level rise from the IPCC's latest assessment report, which members of our Climate Impact Lab team contributed to. The sea level rise projections on the Human Climate Horizons platform are sourced directly from the IPCC, then aggregated to more than 5,000 coastal regions spanning the globe. Users can explore median projections along 3 pathways. The brown line, very high emissions, which results in 77 centimeters of sea level rise globally by 2100 and is illustrative of a fossil fuel dependent future. The pink line, intermediate emissions, approximately in line with countries carrying out their current policies and leading to roughly half a meter of sea level rise by 2100. And the purple line, low emissions, which is consistent with limiting warming to below 2 degrees Celsius and 44 centimeters of sea level rise globally by 2100. The Human Climate Horizons platform offers an accessible way for the public to learn how local sea level rise is likely to unfold in coming decades, all based on scenarios developed by these global research teams. We present local projections in centimeters for populated coastal and low-lying regions worldwide. The scenario here is that intermediate emissions line. Studying these coastlines where people are living today, we see sea levels by mid-century are expected to be an average of 18 centimeters higher than they were in the first decade of this century. But the magnitude of sea level rise will vary from place to place, depending on global greenhouse gas emissions, ice sheet instabilities, and local atmosphere, land, and ocean dynamics. In the Philippines, for example, we see oceans are projected to rise nearly 1.5 times the global average. And turning to the Gulf of Mexico, where climate models show oceans have already been rising at a rapid rate, we see this part of the world is also projected to face more sea level rise than average. Using the country-level view of the platform, we can examine projected sea level rise for coastal communities bordering the Gulf of Mexico, that C shape on the right side of the country. The line chart on the left margin shows an average for all the coastlines bordering the country, while the map makes it possible to determine local changes. We can also look at the US Gulf Coast. The royal blue along the southern part of the map tells us that sea level rise here is projected to be much greater relative to other parts of the US coastline. We can zoom in on specific Texas and Louisiana communities, many of which are projected to see 2.5 times the global average level of rising seas by mid-century. In Houston, that's 47 centimeters by mid-century, and in New Orleans, that's 46 centimeters. Some of the counties just south of Houston are projected to see half a meter of sea level rise in just 2 decades. Impacts on coastal communities include the threat of permanent inundation of low-lying land adjacent to the ocean. The data here maps those sea level rise projections to a satellite-based elevation dataset to explore which places may be submerged in the absence of shoreline defenses. Here, we are looking at the percent of territories, countries, and the globe that is projected to be inundated by mid-century under that intermediate emission scenario. Comparing impacts to each of these coastal countries and territories, as this stacked plot does, we see that places that are most at risk of losing significant parts of their land, and how that projected inundation increases over time. Many of these are small island developing states, like the Maldives, which is projected to lose more than 10% of its territory by 2050 relative to a future with no climate change. Similarly affected are the Marshall Islands and Tuvalu. When we look at this same metric in terms of the amount of land mass lost, we see Brazil's coastline is significantly exposed to permanent inundation by rising sea levels. Looking more closely at the country, we see Rio de Janeiro is projected to have 2% less habitable land in 2050 compared to a future with no climate change, and 7% less by the end of the century. That is well above the average for coastal communities in Brazil. Santos looks similarly at risk, with 3% of its land projected to fall below sea level by 2050 and 7.5% by 2100. Overall, without shoreline defenses, Latin America and the Caribbean are projected to lose significant and critical parts of land and infrastructure as a result of climate change's impact on ocean levels. Another consequence of higher sea levels is increased exposure to flooding, which can threaten people and property in coastal communities. The platform shows how 20-year floodplains, that is an area with a 5% annual coastal flood risk, are projected to evolve under different emission scenarios. Essentially, here we see higher sea levels, giving the storm surge caused by hurricanes and cyclones a higher starting point. This allows that surge to push further inland. This 20-year floodplain is modeled on top of the current mapping of where people live to enable us to say how much more of the population is exposed to flood risk relative to a future with no climate change. Hundreds of highly populated cities will be exposed to increased flood risk, including land home to roughly 5% of the population of coastal cities, including Kolkata, India, by mid-century, and that exposure doubles to more than 10% by the end of the century. The proportion of people exposed to floods is projected to increase in 196 countries across all parts of the world in the next 20 years and beyond, even under a low emission scenario that's consistent with limiting warming to 2 degrees. But the magnitude of that impact depends a lot on our decisions shaping the future course of greenhouse gas emissions. As an example, here again we see that red plot comparison with a line highlighting the global average. At the end of this century, climate change-driven sea level rise increases the share of the global population living in the 1 in 20 floodplain to 1.2% under a very high emission scenario. If we assume the same amount of global population, that's 97.6 million people living in the 20-year coastal floodplain. Climate action to put the world on course for low emissions and limit warming to 2 degrees Celsius reduces the population at risk to 0.73%. Or, put another way, in 2100, our climate action would insulate roughly 38 million people who would otherwise be exposed to flood risk. That sums up the latest data release on the Human Climate Horizons platform. Thank you so much for your time and attention, and I hope you find the information valuable in thinking about our collective climate future.
Well, thank you, Hannah. Now we are going to turn to Heriberto, who's going to join us online to tell us a little bit more about the implications of these new findings on human development and on policy and decision making.
Thank you so much, Admir. Can you hear me?
Yes, loud and clear.
Very good. So it's my pleasure to be here. I'm going to try to share my screen now. Okay. Very good. So I'm going to be talking today about human development and the Anthropocene data for agency. In our office, the Human Development Report Office, we have been talking over the last few years and doing research about the connection between the Anthropocene and human development. And here we're emphasizing the importance of understanding that we are part of the same system in which we have, on the one hand, some planetary imbalances. One of them very important is climate change. But on the other hand, we have the interaction with social imbalances. So we have some shocks that affect our societies, in particular creating inequalities, which create tensions, and those results in our inability to address some of the issues, and we tend to create more pressures, and that fits again the cycle. So we are in presence of a vicious cycle that is getting worse and worse. And it's very important in order to understand and in order to make actions, in order to address this issue, to have the data that show us how these interactions are taking place. And in this sense, as we will show, the Human Climate Horizon platform provides a unique lens that help us to clarify what's going on and also to see what are the entry points for policies. So here, something that is important to understand is that climate change is not just one thing. There are multiple things that are happening. As Hannah explained, we are now releasing the new information about sea level rise and its effects on people. But we released last year information about other layers, other effects of climate change related to increasing temperatures. You see in the bottom panel the effects of higher temperatures in different parts of the world, in particular the number of days above with temperatures above 35 degrees. And something that is very evident is the heterogeneity of the effects. So these are very different. They are affecting also different parts of the world. And at the same time, as we will show, these have different consequences on people, and in particular in the generation of different type of inequalities. At the same time, something that is coming very strong in this model is that the effects are getting more intense with the pass of the time, so they are intensifying exponentially. And also, I will show how there are different spaces for action. Here, there is an example related with the new release. So we have the case of Brazil, and you can see how the communities that are, the coastal communities are the ones that are more exposed. And this is the nature of this layer of effects of sea level rise on the situation of people living closer to the coast. But at the same time, we have information about what's happening with temperatures. And you can see that in the case of temperatures, the biggest increases in temperatures above 35 degrees by the end of the century are happening not in the coast, but in the interior zones of Brazil, in particular in the Amazon. So this is very important for policymakers because it allows to understand what zones are going to be affected and the nature of the effects that these zones are going to be facing. And it allows to see, for instance, what are the areas that are facing both shocks. And this is one example, the city of Belém, where around 12 in the worst case scenario, around 12% of the population will be exposed to high probability floodings, and at the same time there would be a very sharp increase in the number of days that are extremely hot, and of course this will have multiple effects, including a very significant increase in mortality rates to 22 per 100,000 people by the end of the century. So a big effect of climate change is expected to be an increase in mortality, in inequalities. Here, we are talking about the climate change as that could turn into an inequality bomb. In this chart, you see what is the change in death rates due to global warming in different zones of the world. And you can see how the effects is going to be very different in different regions. These are averages, so there are exceptions within the regions, but on average, you see that the more developed countries in the world actually are going to experience a decrease in the mortality caused by global warming. And some regions like Arab states or South Asia will see a very significant increase in death rates, in some cases comparable to today's rates associated with heart disease or cancer. So, of course, this is expected to create social dislocation, and unfortunately, greater inequalities are expected to make collective action even harder. So this is part of the vicious cycle I was mentioning before. Something that is also very worrisome is that this is not only happening across countries. Even within countries, we see some of the same dynamics. This is just one example. There are many around the world of Uganda. To the left, you see the effects of global warming on mortality. The areas in blue are parts of Uganda that are going to be decreasing, where we will see a decrease in mortality rates by the end of the century. This is the worst case scenario with very high emissions. And in the areas in orange are areas where there would be an increase in death rates because of global warming. So very different situation for different zones. And something that is important to have in mind is what we have in the right panel. These are the levels of multidimensional poverty index in the countries, and it's pretty evident that in general, in the areas that that are expected to face the hotter conditions and increases in mortality rates are the ones in the northern part with higher mortality rates, and the ones that are going to experience a decrease a decrease in death rates are the ones with lower multidimensional poverty. So in this case, there would be an increase in inequalities within countries. Again, this is expected to increase the social tensions, and therefore there is a lot to do. So how to break the vicious cycle? We are emphasizing that this platform should be seen as a space for enhancing agency around the world. On the one hand, the platform shows how important are the mitigation efforts that are being discussed in the COP and in other fora. As Hannah shown, there is a big difference in the different scenarios for the different emission pathways. But something that is also very critical are the adaptation efforts. Because even with moderate emissions, our estimate shows that around 40 million people could die because of higher temperatures from now to the end of the century. So, and this is not destiny. This can be changed. The platform also shows that even with low emissions, around 60 million people are expected to face high rates of flooding exposure. So, and again, this is something that can be addressed. There are multiple actions that communities can take in order to prepare for these trends that, as I said, are going to be moving exponentially through the rest of the century. So something critical in this platform is that we can see with a very high level of precision where these problems are expected to happen, and therefore action can start at the local level right now based on this information, and also this information can support the loss and damage agenda and its implementation. So something important that this is an effort that is not isolated and doesn't end with the release that we are having with you today. on the one hand, we will continue to explore this agenda. We are using the motto beyond income, beyond average, beyond today, because climate change is multidimensional, has a global and local dimensions, and also we want to provide information with a forward-looking lens. And we plan to include new layers, hopefully next year, talking about the effects of climate change on crops. And also, we are trying to explore some behavioral aspects. So what happens as a result of these effects with human displacement, with conflicts, etc. And also, we are pushing forward some efforts that are complementary. So for instance, using satellite data and artificial intelligence to measure human development everywhere, and also to try to develop better indicators about multidimensional poverty, so we can contextualize in a better way the effects of climate change. So now we have this new generation of data. So I think we can claim now that we have an abundance of data because we have information for what is expected to happen in every part of the world. Now it's very important that we work on a new generation of policies, and the Human Development Report in 2025 will precisely re-examining the policies in the context of the Anthropocene. So I invite you all to remain in touch. Thank you very much.
Thank you, Heriberto, so much. That was very insightful, very detailed. Thank you so much. So now to conclude or the last segment of this, I'll just have one follow-up question for both of you. First for Hannah. Hannah, if you can hear us, if you're connected, could you tell us more about what's coming next in terms of research from Climate Impact Lab, and specifically research that's coming onto Human Climate Horizons data platform?
Sure, thank you for the opportunity to answer the question. As Heriberto mentioned in his presentation, the next piece of research that we anticipate adding to the platform is an analysis examining how global food production will be impacted by climate change. I can share some key takeaways from this agricultural research. That is, first, what seems universally true about the impacts of climate change on people is that they're going to be worse if your country is hot, or if it's a poor region of the world. Crops are a little bit different because we're observing plants rather than people. Specifically, this study is about the 6 staple crops that comprise 70% of the calories that we consume globally. So agricultural impacts are multidimensional, complex, and not quite as neatly patterned as some of the impacts that are already on the platform. Second, relatedly, despite the flexibility of the agricultural industry and how advanced farmers are in adapting to the weather, production in the world's bread baskets is highly dependent on climate and thus significantly at risk in a changing climate. And then third, I would add fewer calories produced globally in a world of high emissions means public health will be impacted. And so this analysis is also able to talk about what the effects of climate change are on global calorie consumption and how our food systems are at risk. In addition to that agriculture research and all of the impacts on the platform are part of the social cost of greenhouse gas estimates that the lab is continuing to focus on as part of its research. And something that's been discussed in this event is the heterogeneity, the inequality that's evident. And so one of the focuses of this social cost of greenhouse gas research, which is a very important policy tool for essentially cranking up the lever on any of our mitigation efforts, is to value that inequality, to bring in the principle of something called equity weighting, which means that when climate damages occur in a poor region of the world, that would contribute more to the social cost of greenhouse gases than equal climate damages occurring in a wealthy part of the world. So bringing that frontier of climate economics and climate science into the social cost of greenhouse gases
is another major focus of the Climate Impact Lab's research right now.
Thank you, Hannah. That's actually very, in context of today's date, right, on food, agriculture, and water, I think it's very relevant intervention. So similarly for you, Heriberto, if you could tell us more about research coming from Human Development Report Office, particularly emphasizing water, again, in context of today's thematic day.
Thank you, Amir. We are exploring the issue of water from multiple perspectives. And again, this is coming back to the idea of trying to understand the system, the planetary system, and the connection between what is happening at the planetary level, but also in our societies. So we have been working in one project, for instance, with the City University of New York, to characterize what is happening with water security around the world and what are the effects on human development, and trying to determine the nature, the specific nature of these effects in different parts of the world. Things, for instance, that are also related with other problems, other inequalities. This is the case of gender inequality. So we have been documenting that in places where there is a water shortage, there tend to be also places where there are very high levels of gender inequalities. And also we are able to capture this through our multidimensional poverty index, where there are indicators that are connected with how households have problems trying to get water. People, in particular women, have to walk long distances to bring water, and also there are issues of sanitation. And we are trying to understand also how this effect, these deprivations in access to water and sanitation are connected with other deprivations, for instance, in connection with health. So we have made a lot of effort going in this direction, and hopefully very soon we will be able to connect this more with what is happening with climate change. Something important in this agenda is also the policy dimension. So what to do, and something that appears very clearly in the joint work with CUNY is the importance of blended approaches in order to try to address the issue. So it's not only about the use of gray infrastructure, traditional engineering infrastructure. It's also very important to open the space for green infrastructure. So things that rely on nature-based solutions. Some people use that expression. So we can address some of the issues of water security. And something that is very relevant is that as much as we would like to rely more on nature, sometimes it's possible, sometimes it's not possible, and this is why this research is so important, because we are trying to have maps that can give us the potential in different parts of the world. So I'm gonna leave it there.
Thank you, Heriberto. Thank you, Heriberto, so much. And now I just want to check with our hosts here if there's any questions online or any raised hands. Or I don't know if you have capacity to answer those questions. Yeah. Yeah.
Thank you very much for the presentation and also the explanations. My question would be to what was mentioned about data and policy in practice, because a lot of the mitigation and adaptation solutions we see, for example, desalination plants, mangroves, or nature-based solutions are in coastal regions? And is this data we now have already applied in future-proofing these solutions? Because with the sea level rise, there might be issues coming up that sort of destroy these solutions and makes us start from scratch again.
Yes, the natural environment is certainly an essential part of modeling any sort of coastal impacts. The platform does not capture future adaptation, so I think that maybe gets at the question that you were asking. We're not attempting to model how these natural adaptations along coastlines may evolve into the future. It's really, in that way, giving you a view of what areas of the world are most at risk without taking these adaptations, and can also help us think about the wealthier places of the world that are more equipped to do so, and where you see significant risk in a region that doesn't have, that may not have the resources to respond to this sea level rise. So we can, begin to move forward that conversation about funding for adaptation and funding for loss and damage. Thank you for the question.
Thank you, Hannah. Thank you so much. Heriberto, over to you.
Yeah, very, very shortly. This is a very important issue. As I mentioned before, this platform shows that even if we are very successful and to lower emissions, still around 60 million people will be facing the high probability floodings. So by the end of the century, but we have time, and this platform shows us where the effects are expected to occur, but there isn't a one-size-fits-all solution. And so the communities are the ones who have to figure things out in terms of what is the best fit for them. So in some cases, it's more like the development of infrastructure, seawalls. But in other cases, there's plenty of space for some nature-based solution. So, but it's critical that the communities start thinking about that in connection, of course, with the authorities and the national governments. And of course, there are some countries that require help, and therefore there is plenty of opportunities for international cooperation. Over.
Well, excellent. Thank you, Heriberto, so much. So with this, we are now coming close to this event. Thank you, everyone, for following us. And please follow the ongoing work of Climate Impact Lab and Human Development Report Office, and follow the next release of Human Climate Horizons. Thank you very much, everyone.